Question number 12. We have this equation y equal x cubed minus 5x square plus 5x plus 2. Find the dy by dx. So we'll find dy by dx 3x square minus 10x plus 5. The point P and Q lies on C. The gradient of C at point P and Q is 2. So if I take this point is P, so gradient, so tangent line dy by dx is 2. Now Q also the gradient of Q also parallel to this, should be parallel. If I take this point, so and if I draw a tangent, that this tangent and this one is not parallel. So what is the best place to get the Q to parallel to P? So if you pick up here, it's going to be, no, it's not parallel. It's not parallel. So if you pick up something here, so I can see that this one and this one parallel. So this is going to be Q. Dy by dx on this Q also 2. Find the so P x coordinate is 3. So in this point x coordinate is 3. So if we want, we can find y as well here. And now find the x coordinate of Q. So we want to find the x coordinate of Q. We'll make this one the dy by dx at P dy by dx equal to, now we'll make into 2, 3x square minus 10x plus 5 equal to, now we can see there are two answers. One is this one and other one should be this one. So 3x square minus 10x plus 3, 5 minus 2, 3. So I can break this one out. 3x minus 1 and x minus 3 equals 0. So 3x equal 1 or x equal 3. So 3x, it means x equal 1 over 3 or x equal 3. Now we have a 1 point, this is 3. Then the remain is this one. Right? X coordinate of Q is 1 over 3. Now we found out 1 over 3. Now part B1 we done. 2. So we want to find the coordinate of tangent line, equation of this tangent line. How do we do? So we have the gradient, then we need a point on this line. Then we can find, because y minus y1 equal m times x minus x1. To apply this one, we need a point and a gradient. Gradient we have already in our hand. X value also have, I need a y value. So we'll substitute to get y. When x equal 3, y equal 3 cube, 3 square plus 5 times 3 plus 2. So you will get this one as minus 1 equal minus 1. So 3 minus 1 point now. Now we can write the equation y minus 1 equal m times 2 times x minus 3. So this has become y plus 1. This is 2x minus 6. So y equal 2x minus 7. This is y equal mx plus c form. M equal 2 we know, c equal minus 7. Now part 3, this line will cut this x and y axis in this place. So R and S. Let's say this is R, this is S. So we want to find the RS distance. So how do we find the RS distance? If we know these coordinates, we can find. So how can we find the coordinates? Now we have, okay, we'll start here. We have the equation y equal 2x minus 7. At R, x value is what? X is 0. X value is 0. And when x value is 0, hence y is 2 times 0 minus 7 minus 7. So R is 0 minus 7. Then at S, which one is 0? Y value is 0. At S, y equals 0. Hence 0 minus 2x minus 7. So x equal 7 divided by 2. So 3.5. Now, so this is 3.50. Now we have the 2. This is 3.5. Now length of RS. How do we write x? What is the formula? RS. x1 minus x2 square plus y1 minus y2 square root from Pythagoras. So then x1, I will start from here. 3 minus 3.5, 0 minus 3.5 square plus minus 7 0 square root. So this value you will get 7 over 2 square root 5. So this is 3.5 mean 7 over 2 square plus this is 7 square root. Now this is 7 square 2 square plus I will make 7 square. I am going to take 2 square out, so I need a 2 square. I multiply and divide, so it is still the same. Then I will take 7 square 2 square square root out. Then what is the remaining here? This is 1 and this is 2 square root remain. So this is 7 over 2 and this is 1, 2 square is 4. So 7 over 2 square root 5. Question number 13, you have a curve. This curve is y equal 8 over x minus x plus 3x square, and there is a point, this is x to x equal 2 point, we don't know y value. So they want to know the tangent line equation, this one, and for this point if you draw a normal, the equation of that. So we need to find this point first, because when you find the gradient we need this point. So let's simply find the point y equal when it's equal to y equal 8 over 2 minus 2 plus 3 2 square. So this is 4 minus 2 plus 12. 3 2 square 4 4 times 3 12. So this is 10 10 plus this is 14. So this point is going to be 14. Now we'll find the gradient of this tangent line, which is gradient at point x equal to. So okay, first of all we have to find dy by dx. Okay, dy by dx is, so y equal 8x minus 1 minus x 3x square. So dy over dx is 8 times minus 1 x minus 2. This is 1, this is 6x. So this is minus 8x square equal minus 8x square minus 1 plus 6x. So at x equal to, dy by dx equal minus 8 2 square minus 1 6 times 2. So this is 2 square 4 minus 8 divided by 4 minus 2 minus 1, and this is 12 9. So you found out this gradient is 9. Now we have the gradient and the point. Then tangent is y minus y1 equal m times x minus x1. Y minus y1 is 14 times m is 9 times x minus 2. So y minus 14, this is 9x equal 18. Y minus 9x equal, if you want to keep y equal mx c first form, y equal 9x minus 4. Now we need the normal equation. 90 degrees one. If I take m1, so we know that m1 times 9 equal minus 1. m1 equal minus 1 over 9. So we know this gradient now. Minus 1 over 9. Again, so this is a equation of tangent. So equation of normal. Y minus y1 equal m minus x1. Y minus 14 equal minus 1 over 9 x minus 2. So y equal minus 1 over 9x plus 2 over 9. This minus 14 become plus 14. So y equal minus 1 over 9x plus 128 over 9. You can, this is y equal mx plus c form, or you can keep differently. You can multiply by 9. 1 equal minus x plus 128. So 9y plus x equal 120. Question number 14. Normal to the curve. There is a curve. That curve is 2y 3x cube minus 7x square plus 4x. It means divide by y equal 3 over 2x cube 7 over 2x square plus 2x. At point 0 0, and 1 0, the normal to those points meet at and intersect. Okay, so basically this is 0 0 and another point 1 0, the normal. So this is the tangent. It means curve is going to be like this. Let's say something like this, or maybe in a different way. From inside, I draw like this to get an idea. So this is the curve. In this point, you have a tangent. So this is the normal. And in this point, this is the tangent and this is the normal. So this is O and this is A. Now we want to find the equation of this is, I will take L1 and L2, equation of L1 and L2. Now first of all we'll find the tangent to find the point is there. So if I know the tangent gradient, then I can find the normal gradient. So we'll find dy by dx first. 3 over 2, 3x square minus 7 over 2, then 2x plus 2. This is going to be 9 over 2 x square minus 14 over 2 x plus 2. At 0 0, at 0 0, or when x equals 0, the gradient. So dy by dx x equals 0. 9 over 2 0, 14 over 2 0, plus 2 equal to. So tangent gradient is 2 dy by dx. Then the normal gradient. If you take this is m1, gradient of normal is m1 times 2 equal minus 1 m minus over 2. So this is minus 1 over 2. Now we can write the equation. Equation of normal at O. So y minus y1 equal m times x minus x1. So actually this is a line go through, you don't need this one. 0 0, we know that is y equal mx was form. So y equal m is what? Minus half x. So this is the equation. Now let's find the gradient of this tangent, gradient of tangent at A. Gradient of tangent at A. That is dy over dx when x equal 1. So this is 9 over 2, 1 square minus 14 over 2, 1 plus 2. So 9 over 2 minus 14 over 2 plus 2. So this is going to be 2 and 2. 9 minus 14 minus 5 plus 4. So this is going to be minus half. Yeah, actually it should be minus half, otherwise my sum should be wrong. So basically now these two are parallel. Those two are normal. So this is 90 degrees. It means this one parallel to this one and this one parallel to this one. You can give that argument as well. So if this is minus half, then this tangent has to be minus half. Right? Then this is the normal. This normal equal to tangent of this one. So this is the gradient of this one has to be 2. But we can find it mathematically if we want. This is m2. Sorry, this is m2. Now we found out this is dy by dx is minus half. Then m2 times minus half is minus 1. m2 equal to. Then we know this gradient is 2. So equation of normal at A is y minus y1 equal m times x minus x1. Y minus y1 is 0 and gradient is 2 and x times x1 is 1. So y equal 2x minus 2. This one y equal minus half a x. So now this is y equal minus half a x. This one equal y equal 2x minus 2. So this is the end point. To find end point, so we have to solve y equal minus half a x and y equal 2x minus 2. So we want to simultaneously solve. Basically minus half a x equal 2x minus 2. So 2 equal 2x plus half a x. So it means this is 5 over 2x. So x equal 2 times 2, 4 divided by 5. So x value is 4 over 5. Now from y equal minus half a x, so y equal minus times 4 over 5. So this is going to be minus 2 over 5. So this is minus 2 over 5. In these sums, when you read the sums, even for any sum in mathematics, when you read the sum, the plan should come to your mind. This is what you have to do. The step 1, 2, 3. If it's not come to your mind, your knowledge is not good. But first time you want to learn, you want to see this kind of sums, and then you have to work few times like this, and then you will get a sense out of it. And then it's like when you go to an unknown place, initially you don't know, so you have to go round and round, and then when you go 4-5 times, then you know that. So the same thing in here. So when you work a few sums and the new patterns and the way the question asks, you are familiar with that area. And when you get a question in the exam, you know what to do. The patterns, the steps come to your brain. So before the exams mock text, you can check this one. If the steps comes to your brain, then no mind, then you are fine. But if it's not, there's a problem with your learning. Question number 15. You have a curve y equal x cube 2x square minus 4x minus 1. So they will give a small story. This curve cut the y-axis at point P. So just draw and see a small sky. So this curve cut at P, okay. And So then can you find the coordinates of this one? Yes. So this is something you should be realized, because the y value in this place, x value is 0. Then you can find the relevant y value. So this is all zeros and this is minus 1. So uh, at p x equals 0, then y equal 0 cube to 0 square minus 4 0 minus 1 minus 1. So that's what done now. The the line L is tangent to the curve at P, and cuts the curve at right. So this is P. Right? You have a tangent line. This tangent line cut the curve again at Q. So if you know the tangent line equation, we know point, we can find by d by dx. We can find the equation, and we know the equation of this curve. Then we have to solve simultaneously with this Q point. Then we want to find the distance. So that's all basically. We'll work on it. So dy by dx at any point. So 4x minus 4. So gradient at x equals 0. Dy over dx 3 times 0 square 4 0 minus 4 is minus 4. The gradient of this line is minus 4. Then equation of the tangent, y minus tangent line, y1 equal m times x minus x1. So y minus 1 equal m is minus 4 times x minus 0. Y plus 1 equal minus 4x. Y plus 4x equal minus 1. I will stick with this one, minus 5x minus 1. And now this is the equation, y equal minus 4x minus 1. We know the curve equation. Curve equation is this one. So y equal x cubed minus 2x square minus 4x minus 1. Now I have to solve this one simultaneously. So I will make those two equal, y and y. So minus 4x minus 1 equal x cubed minus 2x square minus 4x minus 1. So I can see minus 4x minus 1 cancel out. And this is 0 equal x cubed minus 2x square. I'll write to this side, x cubed minus 2x square equals 0. When I take x square out, x minus 2 equals 0. So x equals 0 or x equals 0 or x equals 2. So this is a repeated root 2 times. Then x equals 0, we can see that this point x equals 0 is point P. X value of point P and x equal to is the x value of point Q. So now we know this is 2. So we can substitute to this one or this one, we can find x value. So I will simplify into the substitute to this one. So minus 4 times 2. So when x equal to y minus 4x minus 1. So y equal 4 to minus 1 minus 9. So this is minus 9. Now we have 2.0 minus 1 and q is 2 minus 9. Now pq distance is x minus x 0 minus 2 square plus minus 1 minus 9 square root. So this is 2 square 4 plus 10 square 100. So 104. Let me check again. This is wrong. So minus 1 minus 9. So this value is going to be plus 8. So plus 8 is 64. So then this is 68 actually. I can see this is 4 and this is 4 times 16. So when I take a square root 4 out, this is 1 plus 16. So this is 2 square root 617. So let me explain this bit how I did. 4 times 16 is square root. Uh, I write 4 and 4 I can take out 1 plus 16 inside. Now I can write square root 4 times 1 plus 16 like this. Okay, one more step. So 4 and this is 17. So then square root 4 square root 17 2 square root 17. Because we know that when we write m times n square root m square root n, you can come to 60 simply square root 68 and then you can work it again if you want. It's up to you. Question number 16, when you read, find the value of x and the value of y when dy by dx is 0. It means simply you want to find the saturation point of this curve, minimum and maximums. So stationary point, not saturation, stationary point. So y equal x half 48 x minus 1. Then dy over dx is half x minus half plus 48 minus 1 x minus 2. So dy over dx is 1 over 2 square root x plus minus, this is minus 48 x over 2. So when dy over dx equals 0, 1 over 2 square root x minus 48 x square equals 0. It means 48 over x square equal 1 over 2 square root x. Now I'll bring 2 here, 48 times 2. This is x square over x square root x. This is going here. So this is going to be x3 over 2 when you simplify. Because x2 minus x minus half. When you 2 when you take half 1.5. 3 over 2. X3 over 2 is 96. I think I had to rework this sum because the sum is 3 over 2 and this is 3 over 2. So about this, uh, so y equal 3 over 2 x half plus 48 minus 1 x minus 2. So dy over dx. So at stationary points, dy dx equal 0. So that's what they are giving. So 3 over 2 plus x half, 3 over times x half. This is minus 48x minus 2 equal 0. Now 3 over 2x x half over 2 equal 48 over x square. So this is going to be pi over 2. So this is 16. So x half a times x x half a times x square equal 32. So this is x pi over 2 equal 32. So now I need x, then I want to cancel out. So x 5 over 2 times, I want to take 2 over 5. 32 also 2 over 5. So then this is cancel out and this is become x. Now 32 5 over 2. So 32 I can write 2 to the power 5, 2 over 5. So this is 2 to the power 5 times 2 over 5, cancel out 2 square. X equal 4. Never ever try to calculate these things unless in the exam with the calculator. When you're doing normal, try to work like this. Now y equal, now we want to find the relevant y value. So x equal 4, then relevant y value. Y equal 4, 3 over 2 plus 48 over 4. This is going to be 8 plus this is going to be 12. So this is going to be 20. So the point is 420. Now I want to find this is minimum or maximum. So we want to get the double differentiation. So d square y over dx square is 3 over 2 times half a times x minus half. This is 48 times minus 1 times minus 2 times x minus 3. I leave as it is and then minus 2x minus 3. So this is 3 over 4 x square root x, I'll bring down minus times minus plus and then 96 over x cube. Now if this x value is positive, then this whole value answer is going to be positive. At x equal 4, d square by dx square equal 3 over 4 square root 96 2 to the power 4 to the power 3, which is greater than 0. Hence x equal 4 is a minimum. Hence 420 point is a minimum. I don't need to calculate this answer because I can see that is greater than 0. But for the safe side, if you want in the exam, calculate the answer and give it. Question number 17, determined by the calculation stationary point. So we want to find the coordinate of stationary point. So what are the steps? We want to find dy by dx, then make equal to 0, then we want to get x and value, then substitute and get back to this one. Now we'll start. 3x square minus 5 times 2 times x plus 7, which is dy over dx is 3x square minus 10x plus 7. At stationary point, dy over dx equals 0. 3x square minus 10x plus 7 equals 0. So the brackets are 3x minus 7, x minus 1 equals 0. X equals 7 over 3 or x equals 1. Now we have the point when x equal 1, y equal 1 cube, 5 times 1 plus 7 minus 14. This answer will give minus 11. So 1 minus 11 is 1 point. When x equal 7 over 3, y equal 7 over 3 cube, 5 times 7 over 3 square plus 7 times 7 over 3 minus 14. So this calculation will give minus 12 5 over 27. So that is 7 over 3 minus 12 5 over 27. So those are the 2 points. So 1 minus 11 and 7 over 3 minus 12 5 over 12 27 are the stationary points. Question number 18 when you're ready. You can see that this is the function. X is an element of real numbers and x has to be greater than 0. It means when you take the number line, so negative numbers is prohibited. Only the x equals 0 doesn't work as well, because if it is 0, this is x equals 0 is assumpted. 1 over 0 is infinity. So all the this is how few mark. You not darken, just a circle. There are no negative x values. So fx equal x square minus 2 plus x minus 2. Now f dash x equal x square, this is 2x minus, so this is become 0 plus minus 2x minus 3. So f dash x equal 2x minus 2x minus 3. Now we'll find f double dash x. This is going to be 2 minus 2 times minus 3. I'll just keep a gap and I put minus 3 x minus 4. So then f double dash x equal 2 plus 6x minus 4. F double dash x equal 2 plus 6 over x 4. And we need to find when x equal 4, f double dash x mean f double dash minus 4 plus 4 we need to find. So f double dash double prime plus 4 equal 2 times 2 plus 6 times 4 2 plus 6 over 4 to the power 4. So this is going to be 2 plus 6 over 64 times 4. This is we can, so 2 plus 3 over 100 and 128. So, but I think they won't not f double dash 4. They may need f dash 4 because if dash 4, if you found out, you may get 7 over 38 over 32 if dash, not double dash. Let me do a small correction. Sorry about this. This is, I consider this is actually f dash x. My eyesight is not good, so it is f dash x. And this is f dash x. Now f, this is f double prime. This is f prime prime, and this is double prime, and this is double. This is double prime. Um, so at x equal 4, if double, so at x equal 4, double prime 4 equal 2 times 4 minus 2, uh, minus 4 to the power minus 3, you will get this answer is 731 over 32. Now we want to show that the function is increasing. If function is increasing for all x element of R, x greater than, so this is the interval, then f dash x is greater than or equal to 0 in this interval. For x, you can write this one as a 0 to infinity open. Also, I can't write a square bracket because 0 is not included, and this is then f dash x greater than equal to 0. So we want to show this one. So we'll take f dash x is x minus x square minus 2 plus 1 over x. Actually, you can see that this is a x minus 1 over x expansion. When you expand, you will get this one, x square minus 2 times x 1 over x plus 1 over x squared. X to x cancel out, x square minus 2 plus 1 x square. So this one, hence we can write this one like this. Hence this is greater than or equal to 0 for all the values of x, uh, x greater than 0. Hence fx is a increasing function for all x are x greater than 0. And here, when x equal 1, 1 minus 1, 1 minus 1 over 1 make equal to 0. It means that is the, when x equal 1, that is the, when x equal 1, so that is the stationary point. because when you put 1 you can see this value becomes 0. So at x equal 1, um, function is not increasing. It's come to come positively and stop here. If you want, you can give the idea together. Uh, function is increasing for all x are x greater than 0, but x not equal to 1, and x not equal to 1. You can work like this as well, this part. Okay, first of all, find the stationary point. Uh, at the stationary point, if dash x equals 0, then if dash x equal x minus 1 over x equals 0, it means x minus 1 over x equals 0, x equal 1 over x square equal 1, x equal plus or minus 1. But uh, x can't be minus 1 as x greater than 0. Then x equal 1 is at x equal 1 if dash x equals 0. So then you have a number line. So this is 0 to 1 and 1 to infinity. So you can write the function is increasing on 0 greater than x greater than 1 and 1 greater than x greater than infinity. So there is no 1 included here. I'll give two definitions just for your information about the increasing function. So let f be a function. Okay, I'll write it. In here it says that let f be a function of defined on the interval I, and let x1 and x2 be any 2 point on I, and then if fx2 greater than fx1, whenever x1 greater than x2, then function is increasing, the otherwise decreasing. So basically when you take an interval and this is x1 and x2 and fx1 mean y value, so this one you can see uh, this is fx1, this side is fx2. So we will come to the other way around. This is fx2 and this is fx1. So fx2 greater than fx1. For all in this interval, then this is increasing, and the other one is like this. So x2, x1, fx1. So this is decreasing. So this is the other definition. If f is continuous on AB and differential on AB, then if that's a greater than 0 at each point, x is element of open interval AB, then f is increasing on closed interval AB. And if that's a less than 0 at each point, so this is the opposite. That if it is less than, we can't find any equal sign. So this is just for your information. You can't understand what is the meaning of this one. Continuous, the requirement for the continuity, and differentiable, because sometimes this is you can simply understand. Some points you can differentiable. Now this is any point differentiable, but if we have this point you can't differentiable. So then we can't talk about continuity in this kind of point. So because the left the differentiation and right differentiation is not equal, that's why it's not differentiable. So still it is beyond your knowledge, and just let's forget about what there is. If you do further maths in university, yes, you will learn these things. So this is question number 19. We need to find the local minimum maximum. So first of all we want to get dy by dx, that is 3x square minus 12x plus 9, and at stationary point dy over dx equals 0, so 3x square minus 12x plus 9 equals 0. Then when you take 3 out, x square minus 4x plus 3 equals 0, and you can divide by 3, and x square minus 4x plus 3 equals 0. So the bracket is x minus 3, x minus 1 equals 0, x equal 3 or x equal 1. So we have two stationary point at here. So we'll take the double differentiation. D square by dx square. So this is going to be 6x minus 12. So at x equal 3, d square y over dx square equal 6 times 3 minus 12, 8 minus 12 greater than 0. Hence x equal 3 is a minimum. So second derivative test, at x equal 1, d square over dx square equals 6 times 1 minus 12 minus 6 less than 0. Hence x equal 3, x equal 1 is a maximum. So we need the coordinate of local maximum. So 1, and what is the other value? So when you put here y equal 1 cube 6 plus 9. This is 4. So 1 4 is the maximum point. Maximum. Question number 20. We need to determine the stationary point. So we have to find f dash x first. So this is 12x3, and 8 times is 24x square. This is 12x plus 24. At stationary point f dash x equals 0. So 12x cubed 24x square minus 12x plus 24 equal 0. So I can divide everything by 12 both sides. X cubed by 2x square minus x plus 2 equal 0. So this is x cubed. And now we need to factorize. We need to previous chapters knowledge. I can see when I put x equal 1, so 1 minus this is 1 minus 1 cancel out, minus 2 plus 2 cancel out. Basically x equal 1 is a factor. So then I have to divide this one, x cube minus 2x square minus x plus 2 divided by x minus 1. So this is x square, this is x cube minus x square, x square. So So this is going to be minus x square minus x, then this is minus x. So minus x square, this is going to be plus x. Plus x, so this is going to be minus 2x plus 2, then this is going to be minus 2, so minus 2x plus 2, this is 0. So we can break this one. X minus 1 times x square minus x minus 2 equal 0. So then x minus 1, so I check because x equal 1, I put 1 minus 1 cancel out, minus 2 minus 2. Okay, I'll show 1 minus 2 minus 1 plus 2. This is cancel out. That's why I decide x equal 1 is a x equal 1 makes 0, hence x minus 1 is a factor. That's why I divide. So I can factorize this one to x minus 2 x plus 1 equals 0. So x equal 1, no, x equal minus 1 from here, then x equal 1 from here, or x equal 2. We have 3 minimum, maximum, or point inflection. So we'll find the coordinate when x equal 1, and what is y? Y equal 3 minus 8, 3 minus 8 minus 6 plus 24. Actually, you have to substitute and show to get the marks. 3, 1, 4, 8, 1 cube, 6, 1 square plus 24, 1 plus 20. So you will get 33. So this is 33. When x equal 2, y equal 3 to 4 minus 8 to square, 6 to cube, and 24 times 2 plus 20. This is going to be 28. So this is 228. And when x equal minus 1, 8 minus 1 square, 6 minus 1 square, 24 times minus 1, 20. So this is going to be 1. So this is mine. Okay. So I'll write everything. 133, 228, and minus 1, 1. So those are the points. Then we will check double derivative. F double dash x equal 36x square, 12 times 3, 36 x square minus 48x minus 12. So at x equal 1, if double dash 1, 36 minus 48 minus 12 less than 0, what is this one? Maximum. At x equal 2, if double dash 2 equal 36 times 4 minus 48 times 4 minus 12, that is this is 48 times 2, so hence this is greater than 0. This is the minimum. And at x equal minus 1, a double dash minus 1 equal, did you see that I made a mistake here? Because I 2 square, uh, 2 square 4, and then simply substitute here 4. This is a issue with the brain. That's why we need to always follow the steps to avoid. So I violate that discipline, and I was in trouble at that time. So if you simply put the If you write like this, we are not making mistakes. So that is something you have to do. 36 2 square and 40 times 2 and minus 12. Then you simplify, then you correct. Because I assume 2 is square 4, and then I lost my conscious, and then the brain assume that is 4 as well. So because I lost my concentration for a second or a microsecond, and then brain decide like that. So those are the places where you can make mistakes in the exam and everywhere. So because of that, discipline works. When you apply it properly and then calculate. That is why a lot of students will get like they know how to do, but when the results comes, they are expecting A star, but end of it B, because this kind of calculation errors. So F double dash, so 36 minus 1 square, then 48 times minus 1 minus 12. Okay, this is actually greater than 0, so this is a minimum, and this is going to be greater than 0. This is also a minimum. In here you know that x goes to infinity, y also goes to chapter number 4 positive infinity, and x goes to negative infinity, y also, but negative infinity, but y goes to positive infinity. So now you have 1 point here minus 1 1, it's a minimum, and 1 3 133, it is a maximum, and again 228, it is a minimum, and x goes to infinity, this is go this direction, and minus direction, it is go to this direction. So then right, so this is minus 1 1, this is 133, and this is 228. This is the sketch.